Now we continue it. Then R, very easily Pythagorean law, R square is equal to x square plus y square. So R is equal to root over x square plus y square. We cannot take plus minus both sides. Minus cannot be because it is a distance, and it must be a plus sign, sign. So it is root over x square plus y square. And alpha can be calculated as we know that sine alpha will be OA by OP, means AP by OP. AP is perpendicular in with respect to the angle alpha, and this is the hypotenuse. AP by OP. AP is Y by OP is R, and cos alpha is equal to the base with respect to the angle is OA. So OA by hypotenuse OP is equal to x by R. Now tan of alpha will be tangent value. Tan alpha is equal to sin alpha by cos alpha. So it will be y by R into it reverses R by x. R cancels to y by x. Therefore alpha is equal to tan inverse y by x. Now we calculate any value of position vectors and its directions also through this process. There are also many properties are of vectors, like if you understand simply, then we have to know the behavior of the position vectors first. Position vectors, as I have described, its magnitude, to calculate its magnitude or its direction, as well as if the position vectors also meet the requirement of basic properties like addition, subtraction, multiplication, also as well as division can be said. Addition is very easy, like addition properties of two or more vectors. Let we consider two vectors. Let one vector one position vector is OP and another position vector is OQ. Then we calculate the we first represent it in a diagram, Cartesian product, Cartesian diagram. Let P point is here, it is X, it is Y, it is O, it is OP, and there is Q point, it is OQ. So if we want to the third vector, this is PQ vector, then PQ vector's direction to calculate it is very hard to understand. Please attend here. If we want QP vector, then its direction is there, it is QP vector's direction, and if we want PQ vector's direction, then it is PQ vector's direction. So we have to know a theorem or triangle property of vectors that uh, the any two vectors uh, after addition of any two vectors, the if we consider a triangle, and if we present two vectors by in this way, if we consider triangle and in the same side, same um, uh, direction, we consider two vectors like a vector and b vector, then the third line of the triangle in reverse order, it is the third vector will be denoted by u. This is their yes, c vector. So a vector and b vector in the same direction, and the third vector is in reverse direction. So it can be just in vectors addition property, a vector plus b vector can be equal to c vector, but is not equal to in both magnitude. You cannot calculate in magnitude in this property. A vector's magnitude plus b vector's magnitude is equal to c. This is not correct. It shows that the vectors are satisfied in this formula, means with magnitude the direction also be considered in this formula. If we if we do not want to consider the direction, just to calculate the magnitude, the c vector calculated by another formula. We will discuss in the next video how the third vector c vector can value can be calculated, and the direction also can be calculated. Subtraction is also very easy. Just we will take b vectors minus means b vectors opposite direction, here is in this way, then the third vectors will be in this way. We can reduce a vector plus minus b vector is equal to, here we get any other third vector d vector in reverse order. In this way subtraction of the vectors is also possible. Both the third vectors, the resultant vector, actually resultant vectors magnitude and direction both can be calculated. In the next video I must show. Please watch and subscribe this channel. This is SAHA tutorial hub. Please share if you like and share with your friends. You must watch another videos. These are very helpful basic knowledge of vectors, and I also discuss another topics of mathematics which are fundamentals to know to solve mathematics harder problems also, as well as to easier problems also. So thank you very much, and watch another videos also.